Good morning. Welcome to Teacher Estelle's Science Kitchen. In grade 6, we are busy with mixtures and solutions. Last time in our previous video, we explored how mixtures can be separated and how they are different from solutions. Remember, mixtures, you can see all the little particles of the different substances. You can still identify each substance in the mixture. While with solutions, you cannot really see the particles. For that purpose, we are going to look at solutions again today. But this time we are going to focus on 3 factors that influence the rate of dissolving. Now remember, the rate of dissolving, rate means how quickly or slowly something takes place. So what we're going to do today, we are going to take our solvents and we are going to manipulate 3 factors to see how fast or slow they dissolve. For that purpose, you will need some glasses. We are just going to use ordinary table salt and sugar again because I know that's available. And I do not want you to waste. So watch carefully how we reuse our solutions that we make. The first factor that influences the rate of dissolving is stirring. Now that we did last time when we made the salt solution, but let's just have a look again because today we changed something. We are going to have a control group. Now the control group will be these 2 glasses. In the control group, you do not change anything because we want to compare how they differ from the ones that we are actually manipulating. So stirring is the method we're going to use. It's one of the factors that influence the rate of dissolving. I am just going to use ordinary table salt and sugar. Now remember, to make it a fair test, you have to use the same amount of water and the same amount of sugar in each of these. Have a look and see carefully what I'm doing. You will wonder why I made them group A, because that is the first factor that we are going to look at. Try and have your glasses filled evenly. This is just ordinary cold tap water that I use, because the amount of the amount of water that you use have to be the same in each of the glasses. Remember now, these are our solutes, the salt and the sugar, and this is our solvent. We are going to make solutions. First of all, I'm going to add 1 teaspoon of salt to our first glass. And I am not going to stir it because that is what we want to find out. We want to find out if stirring helps the rate of dissolving. I'm going to do the same. 1 teaspoon of salt in this glass. Remember, this is our control, so I'm not changing anything. I just added the salt and I'm not changing anything. In these 2 glasses, I'm going to change it by stirring. Now before we go on, you can compare these 2 glasses. If you look carefully, you can see at the bottom, the water is clear and you can still see the salt particles that settled at the bottom. If you look at this one, you can see that the salt particles are distributing evenly throughout the water. We're going to do the same with the salt. Remember now, the salt is our solute, the water is our solvent. With the sugar, I'm going to do exactly the same to make it a fair test. I add sugar to my first glass. Remember, it's my control, so I do not change anything. This one is the experiment. This is the one that I really want to see if there's a difference if I stir it. Good. Here you can see there are sugar particles settling at the bottom and the water is clear. With this one, you can see that there are less sugar particles because some of them have dissolved. I can stir it a little bit more to try and dissolve all of those. Now remember, this is ordinary cold tap water as it comes out of the cold water tap. Much better. There's just a little bit of sugar at the bottom. Now we can call this a saturated solution because the sugar does not want to dissolve anymore. There's no more space for the sugar particles within the small water particles. Now just to make it a little bit more fun, I'm going to manipulate this even further. Maybe you want to wear gloves while you do this. And we are just going to have a look. Watch carefully. I'm just going to, this is ordinary food coloring, just to make it more fun. Let's have a look carefully. If I add watch what's happening. Let's have a look what's happening here. If you watch carefully, you can see that all the food coloring have not dissolved into the water. It has not spread out throughout the water. This is so cool. Be very careful not to shake the glass. Can you see that there's still water that has not been colored? And this one, remember, we want to stir. You can do this with a few drops of different food coloring just to see the difference. This is still not really dissolving into the water. Let's have a look if another color will do the same or have the same reaction. Remember, why is this our control? We do not change it. In other words, we do not stir it because stirring is the method or the factor that influences the rate of dissolving. Can you see that it's a liquid mixed with a liquid? And remember, now this is the one we want to manipulate. And there we have our first experiment. We have now discovered that stirring has an influence on the rate of dissolving. Do you think if I leave these two, the controls like that it will dissolve even further? You can experiment with that as we go along. The next activity we're going to do is we are going to look at the grain size. Now the grain size just means exactly what it says, the size of the grains. Now in these two containers, I am using salt. I've got ordinary table salt and then I've got coarse salt. Coarse salt just means that the grains are coarse, and this is why I said maybe you want to use your salt crystals. First of all, I want you to have a look and just feel the grains. By looking at them, you can see a difference. I marked these two containers B because this is now the next factor, the grain size, that will influence the rate of dissolving. If you touch these, you can feel that they are rough. They are much bigger. These grains are much bigger. So what we're going to do, we're just going to see if the grain size makes a difference to the rate of dissolving. I'm going to use ordinary tap water again. Remember, to make it a fair test, we have to use the same amount of water in each glass. We also have to use the same amount of solute when we mix them into our water. I'm just going to move this out a bit so that you can see what's happening in the glasses much clearer. I'm taking 1 teaspoon of salt. Now I add it to my water, and I do the same with the coarse grains. 1 teaspoon of salt, and I make sure you have the same amount, add it to the water. Now watch carefully what's going to happen. Remember now, these two are our solutes, salt with fine grains and coarse grains, and these are our solvents. If we stir them for the same amount of time, we're going to see what's happening. We're going to have to observe if they dissolve at the same rate. As soon as I can't see any more salt particles in my solution, I can stop stirring and watch carefully now. At the bottom, let's just wait a second for this to get clearer, for the particles to distribute evenly. And in this glass at the bottom, you can see that the grains did not all dissolve. There you can see there's some grains left at the bottom, because the grains are too big. In other words, what is actually happening? The bigger salt particles have to break up first. The smaller the particles, the quicker they break up and can dissolve much more easily. Good. I'm going to leave those two for later. Do not throw your solutions out because we are going to have some fun in the end. The next factor we're going to look at is temperature. Now this is where teacher really has fun, because here I'm going to have tea time. I'm just quickly going to switch on the kettle. And we're going to look at how temperature as a factor influences the rate of dissolving. For this purpose, you have to make sure that you have an adult supervising you. When we worked with a cold water and salt and sugar, it wasn't really that dangerous, except remember, glass is sharp and it can cut you if you have an accident. With boiling water, we have to be very careful. Your parents need to know what you are busy with. Now, in this container, I just have some tea bags, and I've got my 3 glass cups here. Because I'm going to use boiling water, an ordinary glass might just crack, especially if it's cold like today and you add boiling water to a cold glass. So it's a good thing that I have these old cups, because they are heat resistant. I know that because I've had some tea in them before, so I know they would not crack. Watch carefully what we're going to do. Now usually when we make tea, we would add the tea bag in first. For this purpose, we are going to do it differently. my first cup, I am going to pour some boiling water. Now do this very carefully. Remember, we want it to be a fair test, so we must have the same amount of water in each of these cups. In the other cup, I'm going to use ordinary tap water. And in the last cup, I am going to use ice water. Remember to fill the cups with the same amount of water. Now remember, as you can see, this is the warm one, the boiling water, our tap water, and our ice water. Watch carefully what's happening. You can try this with different substances. You don't have to use tea bags. You can use your sugar or your salt, or you can use coffee powder or Milo. Make yourself a nice drink. Can you see something happening? I have not stirred it at all. The rate of dissolving is influenced here merely by the temperature of each of these cups of tea. Good. Now, when we make tea to drink, we actually use all three factors. Have a look. While you're observing changes in these cups, I am going to get myself some milk and I'm going to get some sugar to enjoy my cup of tea. If you look carefully, you can see that this one is gradually starting to dissolve the tea in the tea bag. But look at this one. This one, remember, is my ice water. I'm going to give you a few seconds to watch what's happening. I am going to stir my tea bag in my cup of tea while you are watching what's happening there. Because remember, stirring is one of the factors that influences the rate of dissolving. I'm also going to add 2 spoons of sugar. And I'm going to stir it, because stirring, temperature, we've got stirring and temperature there. Now, if I want to manipulate the grain size, I can either use something like a caster sugar, which is a much smaller grain size of sugar, or those sugar cubes that you can buy in the shops. We can now observe exactly what's happening over here. The colder the water or our solvent, the slower the rate of dissolving. Without stirring it, I can observe that. Now I'm carefully going to take out the tea bags because the tea bag might obscure a little bit of your vision of the water itself. Remember now, I left them for the same amount of time. This one I put in first, so I'll take it out first. Be careful, don't do this with your hands. It is boiling water. I'm used to hot temperatures, so I can do this. And there you can see excellent results. Now we're going to have some fun. You can look on the internet and see how other people are doing this. We're going to make candy crystals, sugar candy crystals. Now this is very dangerous. You have to let your parents help you with this because we're working with heat. Now you can work over your stove and have an adult supervising. You can make miniature sugar crystals because sugar crystals use a lot of sugar. Now remember, I spoke about supersaturated solutions. Now that is a saturated solution, but it's super not because of our superheroes over there. It is super saturated because it's overly saturated. Now you can stir a saturated solution. You can stir all you like. It is not going to help the solute to dissolve into the solvent. But remember now, one of the factors that influence the rate of solution of dissolving is actually heat or temperature. So for this purpose, I am going to use my gas stove. I'm going to use a pot. I am going to use a whole cup of sugar, and I'm going to use warm water. Now, if you're going to work on the stove, remember that you have to be very, very careful not to burn yourself. So the parents have to know what you are busy with. I'm just going to prepare our gas stove. Now you can try this with salt and sugar. For this purpose, you can see my gas flame is burning. For this purpose, I am using coarse salt grains, but first we're going to use the sugar. Now to dissolve a lot of sugar in a little bit of water, we have to manipulate it. In other words, we can influence the rate of dissolving by adding heat. That's why I'm going to use this pot. Remember, we also in grade 5 looked at the conduction of heat. That's why my pot has a special handle. Good. In there, I am going to add a whole cup of sugar. Now that's a lot of sugar. You can use less, but then you have to use less water. Into that, I am going to add the same amount of boiling water. Now remember, I'm going to use one of the other factors. I'm going to use stirring. Now if you stir it and you add heat, you will see that the solvent is actually taking up the solute much quicker. In other words, the sugar dissolves much quicker. So we are going to make sugar crystals. Now to make the sugar crystals more fun, you can also add some food flavoring. I have here vanilla essence. My sugar is boiling, so I can add a little bit of essence to it. Maybe you've got bubblegum flavor or some other flavorings. To this mixture, I can also add food coloring. The food coloring will make it interesting because you can use different colors. You can make different colors of sugar candy and have fun with it. I am just going to show you that I've got a syrupy texture over here. The more sugar you add, the more syrupy it will be. You only need to dissolve the sugar. Now for that purpose I said do not throw out all your other stuff. Remember your solutions that we did when we did stirring. I'm going to add the sugar solution to this, not the salt solution, because I want sugar candy that I can actually eat. That way I do not waste any of Mom's sugar. I'm going to stir it a little bit more. You can see it's changing color there. It's nice and blue, and can't wait for this to turn into sugar candy. Good. I can also use the first one where we only stirred it without changing anything else. And there I haven't wasted Mom's sugar. Good. Now this solution you can let cool down a little bit. Just kill the flame over here so that you can hear me better. You are now going to use your syrup that you made to make sugar crystals. Now remember, this is a very warm mixture that you made over here. When you're going to pour it into containers, make sure that it's containers that cannot crack, because sugar water is very, very hot. We can use ordinary cups like this, but the smaller you make, the more sugar crystals you can make and the less sugar you waste. Have fun, have a look around the internet and see how they make sugar crystals. You already have the syrup, so you might as well go for it. Have fun. See you next time. Bye.